Hello, friends. Welcome to Lura Pharma. It's a YouTube channel to vision your goals in pharma field. It helps you to get knowledge from various part of pharma field very easily, and it very useful to carry your career and reach your goal simply without any complications. We are goal only to utilize the knowledge which whatever we are gaining, it's transferred to students who getting involved in the subject and improve their career by getting knowledge, who want to know about something about extra benefit from the subject. Okay, so without wasting our time, I'm going to start today's topic is dispersion system. Dispersion system in Tamil, Karisal. We have the two phases, which means one is dispersed phase, another one is dispersion medium. For example, if you have one solid particle without dispersed, without soluble, which is distributed through the solvent, whatever it is, the system is called dispersion system. The dispersion system consists of particulate matter dispersed phase distributed throughout a continuous phase. Dispersion medium. They are classified according to the particle diameter of the dispersed material. Based upon the particle diameter, we are classified into three type of dispersion system. First one, molecular dispersion, less than 1 nanometer. Second one, colloidal dispersion, 1 nanometer to 0.5 micrometer. Third one, coarse dispersion, their size more than 0.5 micrometer. Okay, these are the various type of dispersion system based on their particle size. So now we are going to discuss about molecular dispersion system. The molecular dispersion system consists of less than 1 nanometer in size. So the particles invisible in electron microscope. Next, they are very less in particle size, though, so they can pass through semi-permeable membrane and filter paper very easily. Then the particles do not settle down on standing, undergo rapid diffusion. Okay, the very good example of molecular dispersion is ordinary ions, glucose. Next, we are going to discuss about colloidal dispersion. The size is 1 nanometer to 0.5 micrometer. The introduction to the colloidal dispersion. First of all, the colloid was derived from Greek word kolla for glue. Colloid is short synonym for colloidal dispersion. Already I said they have two phases. So we called heterogeneous biphasic system. Okay. Next, the size of the colloidal particles averagely from 1 nanometer to 100 nanometer. But consider nanometer size 1 nanometer to 500 nanometer or 0.5 micrometer. They containing two phases. One is the dispersed phase, another one is continuous phase. Ex- Example, suspension, emulsion. This is the image for you getting very easy knowledge or understanding purpose. I include this image in that the water molecules are consist of only solvent, which means it's the dispersion medium. In the particles in blue color, it is a dispersed phase. In that, the dispersed phase distributed throughout the dispersion medium. In that, the blue color particles phase is a one phase and dispersion medium solvent is one phase. So we called two phases, which means biphasic, heterogeneous biphasic systems. Okay. Next, we are going to talk about colloidal dispersion parameters, which means in these particles do not resolved by ordinary microscope because the particle size 1 nanometer to 0.5 micrometer. So we can easily see with electron microscope. In colloidal particles we can visible by electron microscope, can pass through filter paper but not pass through semi-permeable membrane because the filter paper having the size of little bit bigger than semi-permeable membrane, so it can pass easily. Next, the particles were to settle by centrifugation techniques. Next, its diffusion very slowly because particle size increases means its molecular weight increasing. So the diffusion is affected by its molecular weight. Next, the example of colloidal dispersion. Colloidal silver salts, natural and synthetic polymers. Now we are going to discuss about coarse dispersion. The molecular weight it's very high and the particle size is more than 0.5 micrometer. So the diameter is large means these particles contain more molecular weight. So in these particles are visible under ordinary microscope, do not pass through filter paper or semi-permeable membrane. Particles settle down under gravity, which means gravity means which the particles increase the molecular weight or are easily settled down. Okay, do not diffuse because it's having very large in diameter. Okay, for example, emulsion, suspension or body red blood cells. If you have any extra doubt, you need to know about anything in this particles and this person recording, please contact me by comments. Thank you so much.